Hello everybody, and welcome to our presentation, Wheel Bearing Hub Units and Wheel Speed Sensor Diagnostics, sponsored by BCA. My name is Andrew Markel, and I am the Director of Content for ImportCar and Brake and Frontend Magazines, and the moderator for this event. Again, today's webinar is sponsored by BCA. Wheel Bearing Hub Units with internal or external wheel speed sensors represent a large and growing segment of wheel speed service. Knowing how to diagnose and service these hub units and the wheel speed sensors is a critical skill. This webinar will help you make the right call the first time. Next, I'd like to introduce our trainer. Scott Gonzo Weaver is an ASE Certified Master Technician, shop owner, educator, and writer. His much-loved column, Gonzo's Toolbox, has appeared monthly in Brake and Frontend, ImportCar, and Underhood service for almost a decade. Scott, it's yours now.
Well, thanks, Andrew. Well, today we're going to go over speed sensors and how to diagnose them. And the main thing that we want to travel on is the goals of today's lesson plan. Basically, can a speed sensor be faulty and not set a trouble code? How to deal with intermittent speed sensor failures. Can you test a speed sensor accurately enough to avoid another comeback? Well, the answer is absolutely. That's what I'm going to try to cover here today. So let's get started. The first thing we want to cover is the sensor and reluctors. First off, let's find out what type of sensor we're working with. There are basically two types of speed sensors you'll find in today's cars: the active type speed sensor and the passive type speed sensor. Now, the passive sensor, or reluctance sensor as it's sometimes known, is usually a 2-wire sensor, while the active or magnetoresistive sensor is generally a 3-wire sensor. But it can also be a 2-wire sensor on some applications. They'll use the case as a ground wire instead. Now, both the active and passive speed sensors read a rotational speed of the wheel by a reluctor or embedded magnet inside the wheel hub assemblies. But the big difference is how they send and receive their signal back and forth from the ABS or PCM that makes them totally different from each other. Let's start with the active speed sensor, or magnetoresistive sensor. It consists of 2 parallel resistors, a magnetic material located at a precise distance from a permanent magnet, usually embedded in the sensor housing. And these resistors usually will have a resistance value of about 1,400 ohms. However, if you were measuring the resistance at the connector, you'll probably see something more of the line of 5 or 6 mega ohms. That's because you're not really reading just the resistance of the resistors, but of the magnetic material combined with those resistors. Now, these parallel resistors work together to create a voltage that you'll see on your scanner or lap scope as that tone wheel passes by the sensor. Now, if we flattened out the reluctor or tone wheel out into a nice straight line, the pattern you'll see is shaped like a series of square-shaped saw teeth. Now, these saw teeth pattern matches exactly the square wave that is produced by the tone ring, and you'll see that on your scope. If you notice in our example photo, we've got an example of 4 different patterns that are real common to run into. First off, the normal pattern of just up and down square teeth, then a pattern of a cracked reluctor, a damaged reluctor, and finally a pattern with something metallic stuck between the teeth gaps that's blocking that high and low signal. The way these sensors read is with those groups. And as the tone wheel high side section, let's say, of the tooth comes near the sensor, a high voltage is created, while the opposite occurs when the lower part of the tooth is near the sensor. In turn, what you'll see on the scope are those highs and low voltage readings, one after another, which, like I said earlier, resembles actually the tone ring that you're testing. In most cases, the voltage output is close to the actual battery volts. Now, I've seen a lot of times it tends to be around 10.6 volts, most of the different systems I've worked on in the past. But you won't be able to use a test light to read this voltage signal like a lot of people think you can. A test light basically consists of a ground lead, a positive end, and separated by a small bulb which provides a resistance in the circuit where the case of the test light, the resistant works to produce the light. So basically, resistance, positive, negative, you got a test light. If you looked at a wheel speed sensor, it's more or less two wires with a resistance material, and they'll add a little magnet in there too. But if you try to use a test light as in place of the speed sensor while testing this, the computer will probably see this as an intrusion into its own little world and quite possibly assume the test light is nothing more than a short to ground. In other words, the computer will think that your test light is actually a bad sensor. All the computer knows is that the return voltage it's expecting has drastically changed or is different than the value it's already preset to. In fact, most of these ABS systems, if you do short one of the leads, test light or whichever way, the PCM can just as easily shut that sensor off on the next key cycle or until the next key cycle. Basically, that reference voltage would go from that 10.6 right down to 0. Now, this is one way the PCM can look at it and say, it's kind of a self-preservation type mode. And you won't get the current back till you cycle the key one more time. The big diagnostic issue is if you continue to check the circuit without turning the key off or back on, your search would end up back at the controller. And if you didn't know any better, you're going to diagnose it as a faulty controller. When in fact, if you would just cycle the key on-off, the voltage would return. So when testing these circuits, disconnect the leads from the sensor and the controller. Then ohm check the leads from end to end, then the lead to lead and find if they're crossing over, and finally check the lead to ground before you reach the conclusion that a processor has gone bad. As far as testing the speed sensor, the best tool I've ever found is a good scanner, preferably one that can show you all four wheels at the same time. Of course, a lab scope is more precise, but not always feasible to have the lead stretched across the hood or have the things stuck on the passenger seat. If you were testing the sensor individually down at the wheel or close to the wheel, then a scope might be the best source of information. For me, simplicity is still the answer when I'm diagnosing any type of problem. So whatever tool seems like the best to you is probably the tool you'll want to use. But in any case, there are plenty of methods and tools to choose from. Just choose a tool you're comfortable with and the ones that give you the most accurate readings. Here's something to keep in mind too. These new active speed sensors use a digital signal created by the ABS controller. This type of sensor voltage, like most of the other types, use a Hall effect sensor with a reluctor that produces that square wave. The sensor consists of the two wires, one positive, one negative, and the advantage of this type of active speed sensor are the ability to read more accurately at low speeds than the passive speed sensor does. And it doesn't have to self-generate the voltage like the passive does. Since these sensors use a DC voltage, they can detect not only the speed of the wheel, but also the direction of travel. This allows the controller the ability to calculate not only wheel speed at those low speeds, but be used for other systems such as hill holding or hill descent control features you'll find on a lot of the newer cars. Now the passive wheel speed sensor, on the other hand, has been around a little longer than the active speed sensor. It works quite differently than the active speed sensor does. The passive speed sensor creates its own ASE signal and changes frequency as the actual rotation of this wheel happens. That drawback to this is that the signal is only present while the wheel is actually turning at a rate fast enough to keep that ASE signal out the wires. Vehicles equipped with passive wheel speed sensors generally can't read below about 2 miles an hour. So at that point, ABS system really isn't activated. During wheel spin conditions, though, or under a condition where one wheel is turning slower than the other three, the system can actually adjust the hydraulic brake pressure as needed to allow the spinning wheel to regain traction. The speed sensor signal can be affected by the same things that can affect the active speed sensor, such as weak sensor, damaged tone rings, debris, rust, wiring issues, or more importantly, the gap between the sensor and the reluctor. One of the other common problems is when someone replaces a sensor but doesn't push it in completely. Seen this 100 times. Now, that sensor is too far away from that toothed wheel. In most instances, the ABS controller will set a code, but I have seen this code take a certain amount of drive time before it would actually set. For instance, if you changed a hub assembly out on a customer's car and you've already gave it back to them, but several days later they're calling you because the ABS light has just come back on. After checking the problem out, you find it's related to the same side you just serviced. It could be a sensor wasn't pushed in all the way. It could be a broken wire, or perhaps in the case of a speed sensor that is part of the hub, it may even be a defective hub assembly. Some of the other drawbacks of the passive wheel speed sensors are its inability to operate at those low speeds, or in some instances, even read in reverse. This is one of the many reasons why a lot of manufacturers have gone to the active speed sensor instead. But that doesn't mean that they are not functional or obsoleted on the new vehicles. Oh, by any means, no. In some instances, it's a better choice for the manufacturer to use the passive type speed sensor rather than the active type. Determining which type of speed sensor that is in your car that you're working on is a little tricky. Obviously, checking the manufacturer's specs is going to be a good way, or with a scanner. Although, looking at the sensors themselves, you'll never be able to tell the difference. They can both have two wires, and they both look basically the same. The main difference is that resistance reading. The typical passive wheel speed sensors probably going to run between 1,000 and 2,500 ohms, while the active speed sensor, as I mentioned earlier, is about 5 to 6 mega ohms. But I wouldn't rely on this as the ultimate answer, because if there's a problem with the sensor and that resistance value is wrong, you're going to be wrong from the get-go. Now, in some vehicles, there's a DC voltage set down to the sensor by the processor through its grounding wires. This DC signal travels through the leads and the sensor just like that generated AC signal does coming back up. This DC signal allows the sensor to be tested and the wires by the ABS system without the vehicle being moving. And inadvertently, if a problem exists, a code will be stored that for that particular sensor, and the service light may come on. Keep in mind, this DC signal is used as a way to verify the sensor is actually there, not its ability to create the actual AC signal, or for that matter, to send the AC signal back to the controller. That's entirely up to the rotation of the wheel, wires, and the sensor. Now, with this, as I call bias voltage, a high resistance or an open circuit can immediately be detected. Anytime the bias voltage is not received back to the ABS unit, well, it's going to assume that the sensor is not functioning. Now, you can measure this bias voltage with a lap scope or a voltmeter. However, I've yet to find a scanner that could tell me the bias voltage was present or not. But I'm sure by now there's probably is one. And just to be clear, you can only see this bias voltage with the wheel standing still. If you spin the wheel at all and the AC signal is generated, it cancels that bias voltage signal. Now, if you're reading the bias voltage on a scope, what you'll see is a small voltage increase off of the zero line, just as the key turns on. A typical bias voltage falls about 2.5 volts, with some manufacturers may be a little higher. You could read this with your DVOM, but for this small a voltage change, I think I'd still use a scope. It's a little clearer, a little sharper signal that way. Needless to say, when you're testing any of the connections or components, avoid damaging any of the wires or spreading any of the terminals open in the connectors. Don't stab the wire directly into a sealed wire with your test slide or with your probes, because this is another problem that's going to come back and haunt you from road debris, water, salts, or just about any kind of debris that can happen to get into that opening you just created. Another good point to know is on some vehicles, if the sensor is unplugged or a wire is broken, that bias voltage, of course, is turned off by the controller. In other words, if you're trying to read the bias voltage, you have to leave it plugged in. Basically, any disturbance of those two wires from the controller or to the sensor can be detected by the controller as a problem and cause a loss of that bias voltage. If you don't see a bias voltage and you know this car is supposed to have one at that sensor, it's a good time to start tracing that wire leads back up for any kind of broken or damaged wires. Of course, as I mentioned before, the hub assembly brings on its own sets of problems. In extreme cases, internal and external sensors can be damaged from excess of movement caused by too much in-play in the wheel bearing assembly. A lot of times replacing the entire hub assembly takes the guesswork out of any type of intermittent speed sensor problem. Sometimes the internal issues with a speed sensor are incorporated within the hub assembly. Comes down to an internal breakdown of the material that makes up the rotational parts of the hub. Vernilling or flaking of the ball bearings or races lets some of the small particles of metal float with the grease and surrounding areas. Eventually, some of that material is going to get attached to the speed sensor magnetic surface, and that begins to block the speed sensor signals. Additionally, the speed sensors that are mounted externally can have even more surprises. First off, one of the most common ones is the wrong CV shaft installed, or someone's put a CV shaft in that does not have a reluctor on the shaft. I've seen everything from roadkill to fishing line that has damaged the leads or that have actually ripped a sensor out of the position in a car. Now, intermittent issues with speed sensors come down to either connections or wire leads. Best method I've found is to use an old standard wiggle test that everybody's more common with than probably me. Wiggling the wires near the sensor or along the lengths, especially where the leads are tied down or in a bracket, especially around lower or upper control arms where movement happens. This is where the wire is most likely going to be a problem. 9 chances out of 10, that's where I found the failures at. Some of the other problems I've seen is something hits a wire where the wire has run across a lower control arm and actually busted the wire just from a curb or something they've hit. Even with the hub assemblies, wiggling the wires is still a good method. But if the intermittent fault can't be duplicated or found externally, then most likely it's internal, which means replace that hub assembly. Intermittent problems are always an issue with any type of system that involves electrical parts or anything that moves. A lot of times a sensor can have an intermittent response and not be picked up the controller as bad right away. Loose pins. Loose pins are probably the biggest problem inside the terminals. Connectors, corrosion, oxidation, and things like not securing the leads to the speed sensor back into the brackets can all lead to intermittent failures. Now, I don't think I've ever run across an intermittent failure that wasn't a result of some improper installation or substandard part. If you take the time to do the installation correctly, that means if you find a bracket that wasn't in place when you started, put it back the way it needs to be before you leave. And use good quality parts. You'll likely have less chance of finding or running into an intermittent problem or that comeback. I hope this information in this webinar makes speed sensor operation and diagnostics a bit clearer for you. I hopefully it makes your job of diagnosing a problem with either type of speed sensor much easier. And for that, I'm glad that I can have this time to do this, and thanks for being here.
Thank you, Scott, and thank you to our sponsor, BCA, for sponsoring this webinar. In a few moments, we're going to start our Q&A portion of the webinar. But before we do that, I ask everybody to please take a few moments and fill out our survey. The survey should be popping up on your screen momentarily. If it doesn't, hit the survey icon and it will launch it for you from the toolbar. Now, let's dig into some of the questions from our audience. One question that came up here, this looks like from Joe here. In terms of resistance from end to end on a ABS wiring harness from the connector at the sensor itself all the way up to the ABS HCU, what should be the overall resistance, or should be like almost nothing there?
Nothing. That wire should be as clean can be. Yeah, you don't want to see any kind of resistance in that wire. And something else to think about is don't have any kind of connectors that are not factory in between all that.
And this also, another question we had, this is also kind of related to that. To repair a wiring harness for an ABS sensor, what's your recommendation?
I've got a little trick that I use to splice, where I'm trying to get as many leads or those copper strands to touch each copper strand. If my only choice is to make a connector, it's a little trick I do. I think somewhere we have some articles on that, but I would avoid butt connectors strongly. But if all cases, if it's possible, get a new connector, get a new wire, a new harness, if you need to.
Okay, and got a question coming up here in regards to the signal itself from active. Is there any? This is Joe here. Is there OE information on the bias voltage in the service information from each manufacturer, or how much does it differ from a Ford to a GM to a Honda?
Well, that's a good point, because I have not found a way that I can just search just to find bias voltage. Sometimes it's mentioned and sometimes it's not. But if you use 2.5 volts as kind of a reference as the signal that you should see, that's probably about the best information I can give you. Other than that, all I can say is good luck finding it, because it is like looking for hen's teeth sometimes, trying to find it in the manufacturer's books.
Okay. And another question for passive sensors, can metallic debris build up on the outside encoder ring of a active wheel speed sensor? Absolutely.
Oh yeah, any place that something can build up, and it doesn't have to be magnetic. You can have a grease or oil on the surface and have metallic particles start to stick to it and then mess up the signals.
So another question coming in here, as far as the resistance on, question is, passive wheel speed sensors, what's the general range? I know we covered it in the webinar for resistance of a passive sensor. And what does either an open or excessive resistance mean?
Well, anytime you get past that, or you're not in that range of whatever the factory says it wants for the numbers I gave you are basic, let's say, overall kind of covers most of them. But as far as a high and low resistance, obviously if the resistance is higher, we're going to have a substantial change in the voltage, same as if it's very low resistance. And the computers are set up to read a certain amount of voltage coming back. And that's where it comes back to even with the test light. You're changing resistance there with a test light. But, if you want to get real technical about it, that 1,400 ohms for the one sensor in actives 5, 6 megas, it's just a general rule of thumb. It's just not something I can say is wrote in stone, but check with the manufacturer as far as what the value is supposed to be.
Okay. And we have another question coming in here from Jim, and it is in regards to, I'm going to read this right here. In terms of active wheel speed sensors, is there a general self-check that goes on when the vehicle first starts, and does it occur at a certain mile per hour when that's exceeded?
Well, a good question, because the active speed sensor is active. It's not just going to sit there and wait for it to move. It does do a self-check on them, and that's where that bias voltage comes in. But if you're sitting there with a scanner and you've got active speed sensors, generally speaking, if you're looking at odometer readings or speedometer readings per tire, per wheel, you'll see the thing actually moves pretty darn quick. You don't have to move the car a couple of feet, and it starts to read.
Another question, discrepancy when you're looking on a scan tool from wheel to wheel, back to front. Should there be any discrepancy in the miles per hour shown on the scan tool?
Unless you're going around a corner, nope. That thing should read pretty darn close, let's say within a mile. A lot of times if I'm doing these tests, I'm in my service bay, and I've checked forward and back, make sure I got room to move, and I will sit there and back up and let's say go a car length is usually all you have to do, and I want to see a reading out of all four, and I want them to tell me that they're all basically the same. Now, if I got one that's lazy, it takes a little longer to come up. I'm going to suspect that there's some kind of grime or something on that speed sensor that's causing it to lose signal. So, yes, they should read basically the same.
Okay, and I think we have time here for about 2 more questions. This one comes up. How should you back probe wires? Should it be done at the sensor, or should it be done at the connector for the ABS HCU?
Always go to the connector. If you try to go down at the sensor, and your sensor is the type that the wires are molded into the sensor, that's not a good spot. If you're got the type that is a sensor with a connector at the sensor, then back probe at that connector. But do not stab into wires, especially up in the northern part of the country where they're going to use a lot of salt and whatnot in the wintertime. That little pinprick you put into that wire is going to end up being a big, giant problem real soon.
Oh, I think we touched on a hot topic. We just got another question in here. Back probe or front probe the connector?
Well, okay, if we're calling a back probe, meaning that the connector is connected, and we're going to back probe into the connector, and it is not, quote unquote, a sealed connector, but a connector with maybe, let's say, a weather packing, I'd back probe it. If you're front probing, well, you kind of break all the rules because you'd have to disconnect the sensor to do that. Now you just changed the whole thing up again. I can't see how that would work.
Okay, another question in here is air gap. What does excessive air gap and what does a sensor that's too close to the tone ring look like on a scope? That's from Roy.
Well, Roy, that one, I can't say as I've literally actually looked at that because when I go down and say I've got a problem where I've got a no signal, it's usually the case if it's a wide gap, and you'll see that the type of sensor I'm speaking of is one that goes through a hole that's actually bolted in into the steering knuckle or whatever. It's pretty obvious that the thing's not in all the way, and you take it out, clean the rust out, put a little lubricant in there, and shove the thing back in tight, and then put the bolt on it. Now, too close, I don't know if I'm going to say there's a problem as far as the way it senses. I guess it could be too reactive, but honestly, I've not seen that. The biggest problem I could think of if it is too close, and that would be road debris. Has a better chance of breaking the sensor off if that gap's not there. Probably would never happen, but that would be the only thing I'd see about close being too close. But it could read that way.
Oh, we've got sort of a question here. It's actually more of a comment, a tip from one of our attendees. He's saying, make sure that you use dielectric grease around some of the connector to seal it from water intrusion. I think that's great advice.
Yes, it is. And, that is really good, except the excessive use of it defeats the purpose of using it. So just enough is good enough. But then, of course, almost all the connectors used in area of road debris can get to it generally are going to be weather packs anyway. If you ran across one that the weather pack is damaged, yeah, then I could say put a little dielectric grease on it.
Another one about the harness, zip ties or no zip ties around control arms, and I guess basically his question is, should you make sure that you find the appropriate bracket, or is there ways to improvise?
Well, that's something I'd say that's more of a judgment call. If you're confident that you can put some wire straps in a position that is not going to pinch the wire eventually, is not going to cause the wire to move and twist in a manner that it was not designed to, I would say go find the right brackets. Now, a lot of times when you buy the new sensors, they're going to come with the clips and brackets mounted on them, and I tell you, that's really a big problem, because a lot of times I'll find someone has changed the sensor and came in from another shop, let's say, and you can see that they didn't bother to pop the other clips and whatnot out of the controllers or off the side of the frame or whatever. They just went around it, which defeats the purpose of the whole thing. It's like the new bracket was on the sensor. You just had to pop the other one out of the control arm and stick it back in.
Okay, one last question here. After the hub unit is replaced, could turning the vehicle hard to the left or hard to the right at speed cause a wheel speed sensor to go off or cause a erratic sensor code?
If you're using quality parts and it's the correct part, answer is no.
Great. Well, that finishes the Q&A portion of the webinar today. I'd like to say thank you to all our attendees, and most of all, thank you to our sponsor, BCA. And this concludes our webinar for today. Thank you very much, everybody. And thank you, Scott.
Thank you.